Welcome again to the channel. Today we'll be solving question number 684 of LeetCode, redundant connection, and it is marked medium. Let's first study the problem. In this problem, a tree is an undirected graph that is connected and has no cycles. You are given a graph started as a tree with n nodes labeled from 1 to n with one additional edge added. The added edge has two different vertices chosen from 1 to n and was not an edge that already existed. The graph is represented as an array of edges. So skip the question. The question is very confusing. I'll explain what the question wants us to do. So basically there will be a graph, let's say 1, 2 and 3, right? So this is an undirected graph, right? The question is saying that the graph has no cycle initially, but an extra edge has been put that makes it have a cycle, and it will have only one cycle, right? We have to return that edge that makes it a cycle. Now if you look closely, this edge has been put later, that is correct, but how will we know that, right? Because if you look at it, this edge, if you remove this edge, then also the cycle is broken. That means this could be your answer. If you remove this edge, then also the cycle will be removed, and that could be your answer. And so is the case with this edge, right? So the question states, basically the input will be given to us will be in this format. So 1 2 1 3 2 3. These arrays represent edges, right? So that means 1 comma 2 means it is talking about the edge between 1 and 2. Similarly 1 comma 3 is the edge between 1 and 3, and 2 comma 3 is the edge between 3 and 2, right? The question states, if there are multiple answers, that means we can return an edge, meaning if we remove one of the edges and the cycle gets broken, right, the graph gets converted to a tree, then in case of multiple answers we have to return the last answer. And if you see, the last input is 2 comma 3. The last input is 2 comma 3, right? So this is the edge that we need to return. Now let's look at how we are going to solve this. So we'll take an array called parent, and we'll understand later how this helps us, but we'll take an array called parent, right? Okay, this will be initially however many nodes we are given in the input, it will be the same thing, right? So let's imagine there are 3 nodes, right? So the nodes were 1 2 and 3, right? So in the array we'll have 0 1 2 and 3, right? These indices represent the nodes, right? They represent the nodes, and the value for each node will be itself initially. So 0 will be 0 1 2 and 3, meaning every node is a parent of itself, right? So this parent array represents the parent of each of the nodes. Okay, so let's process the first input, which is 1 comma 2. This was the first edge, right? If you see, this is the first edge that we will encounter, right? So we'll check in the parent array what is the parent of 1. Parent of 1, and the parent of 1 is 1 because it is initialized that way. Then we'll check parent of 2, that also is 2. So they are not equal, right? Not equal. So since they are not equal, we will combine them, right? Because there is an edge between them, right? That's why we have this input. This input tells us that there is an edge between 1 and 2. So that means we can combine them. Now while combining it, so it will be like this, 1 and 2, right? They're both the same level, but we will have to assign one of them as parents, right? Parents for both of the nodes. So let's assume that we'll assign one as the parent. So that means parent of 1 is 1. Now parent of 2 also becomes 1, right? So in the parents array, I'll create another one. Parent array now becomes 0, 1, 1 and 3, right? 0, 1, 2, 3. The parent of 2 becomes 1. That's what we did. Basically we combined them, right? Now we move on to the second input, which is 1 comma 3. So again the same logic, parent of 1 equal to 1, parent of 3 equal to 3. Again not equal, they're not equal, so we combine them. Again same logic, 1, 3, we'll have to assign one of the parents. Now here we can assign 3 as the parent, but that will be a wrong move. That will not help us find the answer. After, since we have made one a parent once and one has appeared again, right? This time we have to make one as the parent, and that will be determined by another array called rank. So initially the rank of everyone will be 0, right? Rank of everything will be 0, so 0, 1, 2, 3. But after the first step, when we made 1 as a parent, the rank of 1 will increase. That means 1 will become 1. Now the rank of 1 is higher than the rank of 3. Since rank of 1 is higher and we have 1 and 3 here, 1 has to be the parent, right? So that means the new array parent modifies to 0, 1, 1 and 1. 0, 1, 2, 3, right? Parent of 1 is 1, parent of 2 became 1, and parent of 3 also now became 1. Now we move on to the third input. So the third input is array of 2 comma 3. Now check, parent of 2 is 1, parent of 3 is also 1, so they are equal. That means they both belong to the same parent. So essentially like this, 1, 2 and 3, right? They both belong to the same parent, and this is saying that there is an edge between 2 and 3, like this, which we do not need, because this will create the cycle. This will create the cycle, and hence our answer will be this array. We'll return 2 comma 3 here. So let's write this in code and you'll understand better. And this method is called union find, and you'll see why it's called that. So as we saw, we have to first initialize the parent array with every node being its own parent, right? So we'll have to first find the length of edges, right? These are the however many nodes we have, because if you see this, you are given a graph started as a tree with n nodes labeled from 1 to n, and we see the graph is represented as an array edges of length n. So that means length of edges, which is n, is the number of nodes, which is also n, right? So n here represents the number of nodes we have. Then we make a parent make array of n, and if you see this, we never process 0, right? Because nodes were 1 comma 2 comma 3. So nodes will start from 1 to n, and that is given in the question also, 1 to n. So that means in the initialization phase of the parent, we'll have to increase the size by 1. So that means n plus 1. Same with the ranked array, make array of int n plus 1. Now we have to fill up these arrays first. So for I less than equal to n, since it has to go up to n, I plus plus parent of I will be I itself, and rank initially will be 0, right? We initialize that way. Every node was the parent of itself, and rank initially was all 0. Okay, and as we further make one of the nodes parent, will increase its rank. Now we define a method find. I'll take an int and will return also an int. So find equal to x int and int. Now if parent of x is not equal to x, then parent of x equal to find parent of x, and will return parent of x. Now what this function does is help us determine what is the parent of the current node. So imagine in the find function we pass 3, right? Imagine we are at this step and we pass 3 as a node in the find function. Now parent of 3 is 1, right? But parent of 1 might be something else. So imagine an array like this. Right? So parent of 6 is 5, parent of 5 is 4, parent of 4 is 3, parent of 3 is 2, parent of 2 is 1, and parent of 1 is 1. Right? So if we ask what is the parent of 5, what is the parent of 5? Will we say parent of 5 is 4? No, because then parent of 4 is 3, parent of 3 is 2, 2 ka 1, and parent of 1 is again 1 only. So the final parent of 4 is 1. That's why we are using recursion here to find the parent. If parent of x is not equal to x, then we move into recursion. If it is, like in this case, parent of p of 1 is 1, that means they both are same, we return 1. That means we have found the parent, right? So that's how find function works. Next we have to define another method, which is union. It will take in two nodes x and y, and it will return a boolean. Now we'll pass two nodes, current nodes, into union, right? How? Because we'll be processing the edge, and these at a time will have two nodes from one edge, right? So we'll pass those into the union function, and we'll find the parent of each of them. So find x, find y, right? So px is the parent of x and py is the parent of y. Now what we did was, if the parent turns out to be the same, then we have found our answer, right? So that means if px equal to py, we have found our answer and will return false, right? Otherwise we will combine them. That's what we did, right? Remember, if p1 or p1 equal to 1 and p3 equal to 3, so parents are not same, we combined them and made 1 as the parent of 3, right? So we'll do that. So if sorry, if rank of px is greater than rank of py. So as I said, in determining a parent, we use the rank whose rank will be greater, that will become the parent. So in this case, if rank of px is greater, that will be the parent of py. So parent of py equal to px. Else if rank of py is greater than rank of px, that means parent of px equal to py, right? Else if both the ranks are same, which will be the case initially, we can make any one of them as the parent. So parent of py equal to px. So in this case, px is the parent of py, and hence since we made px as the parent, we'll increase the rank of px as well. So rank of px plus plus, and we'll return true here. Say the union was successful, right? Here we returned false because the parent was same. We don't want to union it, we don't want to combine it, right? Because that will form the cycle. So that's why we return false here. Now we'll iterate through all the edges, range edges, right? So we'll have x comma y, e0 and e1, right? Every edge is a like a pair of nodes, so we'll have x and y, and we'll try to union them. If not union of x comma y, so that means if we cannot union them, if it returns a false saying that if we combine them, it will form a cycle, then that's our answer. So answer equal to edge, because we have to return an edge, right? Return an edge, right? So we'll have to declare the answer variable, array of int, and we'll return answer, right? We'll keep on doing this. This also ensures that we return the last input, as we talked about, right? If there are multiple edges, breaking any one of them could be our answer. We'll break the last one, last in the input. So we'll iterate the input from first to last, and whichever answer comes last will be our answer. We'll keep updating answer if there are multiple answers, and the last will be the one that we return. So let's try running this. So working. And it was accepted. So this method is called union find method. Basically it groups similar components together. That's the core logic of this method, like grouping things together and assigning one of them as the parent, right? So that was it for this video, and I'll see you in the next one.